There we go. I love that announcement. Okay, yeah, so the plan for this session, we'll record it, and it's really building on what we did around the gong. Tim has very kindly joined us. So I think it's good to have a different perspective on how Tim designs and how we build things, but really the focus now is more on the mechanics. So building things that you assemble, the things that are driven by servos, motors, gears, you know, all the great things that we've kind of seen in some of the builds in the group. And Tim, I think, is probably one of the most prolific modifiers. And every time I think, how the hell do I get chopper's arms to bend in one direction, come up with a solution, stick it out there, then Tim adds another dimension to them. So I thought it'd be really useful to kind of get into the brain of Tim as well to get understanding.
It's a scary place.
Yeah,
that brain.
Yeah. So, do you want to start, Tim, and just go through what you consider when you're putting these things together, or just a little bit of background on the mechanics?
Yeah. So I've got a little slideshow. It's only like 4 slides. I'm not going to do death by PowerPoint. Let me see if I can find it here. Keynote. Here we go. Share. And so is that still sharing?
I've got black screen.
It is. Yeah, well, let me stop share and try this again. Had it a second ago. Well, that's weird. Well, I'll look at my slides and talk to them. And there's a PDF that, oh, okay. So there's a PDF that is included in the same place. Does everybody download the Fusion file?
Yeah.
And upload it into their machines? Stand by one while I find this. Huh. Well, I'm not going to share a screen because it's not behaving itself. So part of the discussion is we got 2 things I wanted to talk about. One is how I do mods, what I'm thinking about when I'm going through and designing it, and 2, specifically, how do I go about working with gears? If everybody can pull up the resources page 2 of that PDF. So
I just put it on there, Tim. I think I'm sharing it so people can see it now, hopefully. Can people see that?
All right. Okay.
Yep.
So
Jeff's nodding. We're good.
Yeah, that's it.
So you're on resources at the moment.
I've got a few sites to help design and build gears. Part of the thing you have to figure out when you're working with gears is what the pieces of the gear are called. They're not complicated, but they're confusing in that a lot of them seem like they're the exact same thing, but they're not. For example, circular pitch and pitch diameter and pitch circle all sound like, oh, you're talking about the same thing, and you kind of are, but when you go to work out the formulas, they're different things, or can be. So in the picture you're looking at there, we see 2 gears, and that pitch circle is basically the radius of the gear if it didn't have any teeth. And what that means is if you took 2 wheels with no teeth on them at all and rolled them against each other, that's how big those wheels would be. And so all you're doing with a gear is you're putting cuts in it and bumps on it so that they mesh better and you can get more torque through that those 2 rolling gears. And that pitch circle is important because when you're trying to figure out how far apart the gears go, you take each pitch diameter, divide it by 2, so basically the pitch radius, and that's how far apart those 2 gear axles have to be. And another key concept is the module, which is basically the size of the gear teeth. And the reason I'm bringing that up is if you're making gears that are going to mesh, the 2 modules have to be the same, or the gears won't mesh with each other, just because of physics. You know, they have to be kind of the same size as teeth. You can have different number of teeth on both gear. As long as the module is the same, those gears will mesh and you can drive one with the other. And we'll kind of leave it at that until we get to the fusion part when we're actually going to build a gear, if we get that deep into it.
I always think of the module as the gap between the teeth, really. So that the spacing of the teeth is probably a more appropriate way of saying it. So if you've got two gears, it doesn't matter how big the gears are, as long as the teeth are spaced in the same gap. If your modules are different, eventually it'll run out of sync. It'll mesh your gears. It'll create all sorts of problems. The other thing that confused me when I first started was that pitch circle, because that's not the round inner part of the gear. The pitch circle is about halfway through the teeth, so it's where the teeth actually mesh. But as Tim said, it's really important with a pitch circle that you know what that is on both of the gears, so that you can get the gap. I don't know what you do, Tim, but I also tend to pull them apart a little bit just to give it a bit of extra play. Otherwise, they can be quite tight if you do it exact.
Right. So the perfect world is we take half of the pitch circle of each one, the radius circle, and then and like today's example, that number is 58 millimeters, but you probably want it 58.5 or 0.25 millimeters. Otherwise, just due to the imperfections of reality, it's going to be too tight and bind. I think I can share this screen. I just want to show a quick spreadsheet, just as let me see if I can do this here. Says you cannot share well another. Can I get the screen sharing for a sec?
Yeah, go for it. Yeah, I think you should be able to do it now.
All right. So let me find, here we go. Okay, so what you're seeing here is simply a little spreadsheet that I went through, and I tend to do this when I'm building gear trains, is just put down the number of teeth, the module, and I put some formulas in there so that no matter what tool I'm using, I can type in the information that tool is asking for, because sometimes they ask for diametral pitch, sometimes they ask for circular pitch, sometimes they ask for the module. And depending on what tool you're using to generate the gear, and I don't ever generate my gears by hand because that's just too tedious. It's possible, but it's a lot of math, and people have already done that work. So I'm just going to stand on their shoulders. And if you can see what I've done here, this is the gears in the lifter that we're going to use. It shows you the number of teeth and the distance, the axis distance that I was talking about of 58 millimeters. Is everybody any questions on that? This is a fairly simple spreadsheet, nothing really dramatic about it, but it just helps me keep my thoughts focused. All right, so I'll stop sharing that, and we'll get more into the gear aspect of it. But before I design anything, there's a few things that I keep in mind for every mouse click I make. And it's not like a checklist or anything, but just a philosophy of what I'm thinking about when I'm putting my thoughts to the screen, if you will. First thing I think about is the strength. How much load is going to be on this piece? Is it going to be bearing the weight of a droid, or the gram or two of a door, a small door? How much force is going to be applied when it's moving at rest? And just, I don't do any math on it, but just a general overall consider how strong does this piece need to be? How thin can I make it? How small can I make it and still be viable? Because I'm always trying to make it less material, do the most economical thing, but never to the point of it's not going to work. I've seen, for example, servo mounts that are functionally the right size, but they're so thin. I'm not accusing anybody here of doing that. But like on Thingiverse, you'll see a servo mount. They're like, that's not ever going to bear the load. So the next thing I think about is printability. As the parts get more and more complicated, you can't just throw them on the print bed and have them print. So first thing I always try to do is make it so there's no weird things at the sides or bottoms that are unnecessary. And if I eliminated them, I could put it flat on the print bed. And if I can't do that, then can I assemble it in such a way that I have two pieces that will sit on the print bed. And if I can't do that, or three pieces, whatever it takes, but it's a balance between printability and then complexity, because now you get to print multiple pieces and you have to assemble them. How are they going to be held together? So step one is I always prefer to make it as simple as possible. But at the end of the day, if I get to the point where the part just needs to be this shape and it's not printable without supports, I try never to leave you to the mercy of the slicer generating supports, because who knows what setting. I mean, it's just one wild card that could cause the design to go horribly wrong. So I will try to always integrate supports into the designs that are in intelligent places and in economical ways for the printability. The next thing I think about is assemblability. How's it actually going to go together? What tools are you going to have to use? Where are the tools going to fit? Are there going to be holes for screws or hex wrenches to be able to fit in? Because I've designed a couple of things I couldn't put together where there's no way to put a tool on the head of that screw to turn it. And in that same vein, I tend to not like gluing things. Sometimes you just have to, but glue's so very permanent, and a lot of my designs are always kind of being upgraded or changed. And since I'm in the modification business by trade or by default, I'm taking something that's already existing and modifying it. So if someone wanted to do the same with me, you'd want to be able to disassemble it, put a new piece on and reassemble it. So I tend to avoid glue, but sometimes you just can't. It just has to be glued. But I just think it's cooler when things screw together. I like screws. I like gears. I like putting things together, like not Lincoln Logs, but erector set stuff. And maintainability, I kind of touched on that. Can you take it apart? Where's it likely to fail? Where will it need to be like new bearings put in over time, or who knows what? So it's always nice to be able to put it together and take it apart. Cost, as little as possible, but as much as it takes. Sometimes if I could spend a long time trying to build what a linear rail does, or I could buy one for $20. So I always try to do 100% 3D printed, but obviously fixtures, nuts and bolts, and bearings. But if it's a special spring or a magnet or whatever, I always try to source that stuff with a link, so that, like, if you go to a hardware store and buy a spring, you may or may not get the same spring I got, and that spring may be dependent. It depends on the like, for example, I'm not sharing anymore, but this little thing here I've been working on for BT1's rocket launcher. The springs are critical to making this structure work. They're too strong, too little. So I always try to source pieces that are repeatable and provide links so that the project can go forward. In that same breath, what materials am I going to print this in or assemble it in? And PLA, PETG, nylon, ABS, and I consider springs, fasteners, and my favorite new thing is magnets. If you can use a magnet, that's the best way of putting stuff together, because you don't need any tools to take it apart. And it's just, they're kind of difficult to get installed, but once you get the technique down, magnets are wonderful. And the last thing I think about is durability. What types of stresses are going to be likely to be found on this piece? For example, Chopper's antenna. Chopper's kid-sized, and like they reach out, and that is eye level with them. They grab that antenna and want to waggle it back and forth. So we didn't realize that until the first time we took them out in public. And the first thing they did was reach up and try to use that as a joystick on Chopper's head. So always kind of think about what environment that mod's going to live in, and what dangers it may face, and if you can mitigate those in your design. So that's kind of the in my mind, philosophy when I'm building stuff is kind of, don't just build a thing that works, build something that has a little bit of purpose in it, and a little bit of, you thought down the road a little bit to avoid the pitfalls and the reason I've come to this kind of list of things is I've made all these mistakes. and ended up with mountains of things that I printed out that didn't work.
It's like
so
it's like mind reading that, Tim. If you were, I feel you're just describing my brain as well. And I think the reason that it's exactly the same is because we've both made exactly the same mistakes and had the same failures.
Yeah, it's a challenging, but it's like if I don't keep all those things in mind, and not like I said, it's not a checklist. It's more of a, when I'm clicking on this and trying to, like, I'll spend minutes to not hours per se, but before where I know what I wanted to do, but exactly how to start and where the point of reference is that the rest of the design is going to grow from. I tend to also delete stuff like Michael does, but I also tend to leave a lot more hanging around because I tend to circle back and try to find the same exact plane of reference I used. And to that, I've got a few tips and tricks that when we're doing the fusion stuff that I want to hit on. I just want to throw these words out and get them in your mind, because when I'm talking them, they're kind of buzzwords that like, that's something that I found is important. First would be sketch constraints. If you've done any sketching in Fusion, you'll know that there's different colors in the sketches. And the most happiest one is when the sketch turns blue in the middle. That means it's a closed sketch. But the other one that may or may not be aware of is when the lines turn black, that sketch is constrained, meaning that you've got perpendicular corners that are perpendicular, you've got tangents that are tangents, and the distances are not, you can't drag them around by accident. So if you throw in enough dimensions and constraints, that sketch will go black on the edges. And the only reason to do that is to make sure that your sketch doesn't have any errors that you can't see, because the errors that you can't see will propagate, and 4 days later in your design, why won't this work? Because you have extra faces and surfaces and stuff that you never intended to be in there, clogging up the works, making the calculations more difficult, and eventually it fails because you've got things that look like they fit together, but they're not even touching in the infinitesimal space that Fusion lives in. To that end, I use the extend and trim tools in the sketch, and I'll get to this at some point where I'll tend to overdraw my lines and trim them back. And I'll tend to, if a line's not connecting, I'll use the extend tool rather than just add another line, because another line adds faces and things that are unwanted. I use construction lines a lot. And again, we'll get more involved with this, but construction lines, basically you can take any line, you hit the X key and it turns it into a dotted line, which allows you to reference it, but it doesn't show up in the final work, doesn't create extra faces, but it allows you to put in all these constraints I'm talking about, and it just for the sketch, it doesn't live outside the sketch. The other thing I do a lot is offset planes. You know, when you're building something, you can click on a flat surface and create a sketch on it. I don't always do that. I may click on that same flat surface and build an extra plane that is offset either 0, so it's exactly the same, or I may offset it with the clearance I know that piece needs, so I don't have to add the clearance later. Let's see, a hole tool. I use the hole tool a lot, and we'll get to see that today. And slice sketch. This is one I recently found out about. I've seen it in the menus, but slice sketch basically cuts away everything in front of your view of the sketch, and at like a cross-sectional analysis. So you can slice and unslice a sketch. And it's a weird term, but it basically lets you look at a sketch, the underlying geometry, without seeing all the other models that are in the way. And we'll probably see that today too. So that's kind of my buzzwords that you can be listening for as we go into the diffusion stuff. And that's the end of my prepared remarks.
No, brilliant. Thanks, Tim. Yeah, and I mean, I'm interested to watch this because I do direct modeling. I don't tend to use sketches only to create solid objects, and then I cut solid objects up. So I use it in a very different way than you do. But I think it's worth, kind of seeing every facet, because as you get more comfortable with Fusion, you tend to develop your own persona of how you actually use it, because you can use Fusion in lots and lots and lots of different ways. Cool.
Yeah, I have been toying with the timeline. I did a recent project where I vowed to use the timeline the whole time, and is the only way to do that is to manage it with components.
Yeah.
And so in the same breath, I at the end of it abandoned the timeline. It just gets too complicated.
Yeah, that's good to hear. I thought you may say, "Oh yeah, it was great," and it all worked for me, because I've tried a few times the timeline, and I've just wrestled with it and just thought, no, it's more trouble than it's worth.
Well, that our duo model that I did is 100% with a timeline, but it's also got components. And the cool part about that is when you click on a component and edit just that component, it has its own timeline, and that really boils down the complexity. But I think it's time to maybe do some fusioning.
Yeah.
So let's go to, let's see, where is it? Fusion. Here it is. Share. All right. Everybody can see my Fusion screen.
Yeah.
All right. If you want to follow along, does everybody know how to import that into a project?
Where are we finding the file at?
Oh. It's a good point, actually. But I was going to put them after the thing, but I can stick it up now, actually. This is the Zapper Armless one, isn't it?
It's Zapper Arm lesson 1. Yes, I think it should be. It's the most recent one.
Yeah,
I think I sent. I know I sent you at least 2. This is the last one. It's the one.
right. There's a folder called Advanced Week 1 in the Fusion resources, and the file will be in there very, very, very shortly.
All right. So while that's uploading, I'll just briefly go over, if you don't know, how to bring it into your Fusion. You notice I've got this little panel on the left side where I've opened it up, and this upload button allows you to select files. And so wherever you download that to, you can select the thing you want to upload to the Fusion cloud, and it'll bring it into your project workspace. And in this instance, it's actually got 2 components, the Zapper Arm lesson 1 and Chopper Arm bearing. Once you upload it, you'll get both of those parts in your whatever folder or project space you are working in. Anybody have any questions? Or
they should be available now, I think.
I'll pause just a second. Everybody, am I losing anybody at all? Or this is basic enough?
Yeah, everybody's on mute, I think, at the moment. I don't know if anybody's saying anything. No. There's
so far so good here.
Yeah.
All right, so so what I did is just open up Zapper Arm lesson 1, and it should open similar to what you see here. And what I've done is I took the Mark III body and I cut it up just so we wouldn't have to keep in a section analysis all day. And so we're just looking at the parts that we are interested in manipulating. And the other part that we're interested in manipulating is the interface arm servo base. And this is all part of the Mark III stock design. And you notice I brought in a servo, and on that servo, I had this little model of the servo arm. And the interesting thing about this particular servo model and arm is it works. This is a valid representation that I've modeled other components off of that if I use the geometry that's presented in this little model, I can then print that out and have a successful build. So I'm going to hide those bodies for a second and turn on this. This is our end state. And that's if you are load up the file, this is the Zapper Arm, and this is a component. And the difference between a body and a component is a project inside a single line on your tree here. So if you look, I've got this is a body, this is a body, and they're all living in this master project called Zapper Arm Lesson 1. But under that, you can see these little things with the colon in their name, and there's a little dot, like a circle next to them. Those are components, and if I activate a component, something magic happens. Everything else in the project goes to this glassy mirror gray stuff, and then my project becomes active. And the important thing about that, the most important thing is every edit, every cut, copy, paste, sketch, plane, everything is now going into this component. You can see it's a complete set of everything that a project would have inside this one component. And if you look at my component here, it's got components. And the reason I do that is if I want to do any animations, they have to be components. So if I were to, whoops, click on this and hit drive joints, you can see I've got this animation. It's not an animation, it's just a physical relationship. So I can see range of motion and conflicts that it might run into. But most importantly, in my gear design of this, I wanted my servo to move less than 90 degrees and my arm to move more than 90 degrees. And the easiest way I could figure to do that is to have more teeth on my drive gear than on my driven gear. So you can see in my design here, my servo moves 60 degrees and my arm will move about 95 to 100 degrees, which the reason I chose to do that is when you're tuning servos, if you're at exactly the limit of the servo, you're going to run into troubles because that servo may or may not deliver a full 90 degrees.
You all right, buddy?
Full... Hello? I can't see anybody else's.
That's okay. Carry on.
Okay.
There's a bit of background noise.
Yep. So if I can have my servo run less than its full capabilities, then I have an opportunity to tweak that servo when I'm installing it and programming it. So I'm not going to run against any hard limits, meaning that I need it to run 92 degrees to get the motion I want. So if I design it to never need the full 90 or full 180, then it's much easier to tune that servo and install it and have it work for me in a snappy fashion. So that's kind of a sneak peek of where we're going, or where I want to go this project. Other things of note is I've got choppers. Let me activate. This is important. I'm going to go back and reactivate the main project. And so this Zapper, completed Zapper is now it's still there. I just turned it off, but nothing's going to be changing on that component. And in fact, if you look at this component here, chopper arm bearing, see this little link, this little chain link? That means that this project or this, this component is immutable. It cannot be changed by me by accident because it's bound to the chopper arm bearing. That doesn't mean I can't change it. I can change it one of two ways. One is I can open the chopper arm bearing and it's as a separate project. Or two, if I go to this little pencil, I can now edit it in place. And this is sort of like editing in a sketch. So I can do whatever changes I need, but I have to come here to this check mark and end that. And that's kind of an important safety tip. If you don't do that, you're going to end up getting confused as to why aren't my edits working? Why did Fusion crash on me? Well, it didn't. You just have to play along with its rules. So this chopper arm bearing is something that I thought would be neat to integrate into this servo lifter, because that's going to give it more stability. So it's not going to rock back and forth. And it's going to be less load on the servo because it's going to have a nice bearing tracking a path. And the biggest reason I thought it'd be cool is that, hey, look, it actually, if I were to go move here, I'll just play here for a sec. Not that, I want components. And I'm going to pick chopper arm. If you look at it, it fits inside of the existing mount. So I thought, oh, it's purpose built to pop right in there. So just as a happy accident, the chopper arm bearing, I can reuse as a kind of a basis for this upgraded arm lifter. So I just hit escape. We'll get back to that as the lesson progresses. So what I did was I cut and pasted or built a new component of this the servo lifter from Chopper's design. And the reason I did that is, again, it's a shortcut. Chopper used this exact same 72 and 44 teethed gear. And since I'd already gone through the pain and trouble of working out that geometry and test printing and finding that servos would work, I just started that as a baseline for doing the model on the Mark III. So the reason it's sitting here in midair and kind of smashed into the lifter is because that's exactly where it needs to be to make my gear geometry work with the rest of the model. So basically, I'm using shortcuts of stuff I know works, and I'll bring it into a project, and often I'll bring it into the project as a component. And when I'm working on that component, I tend to activate it to make sure that all the edits fall inside that component, particularly like if I'm doing motion studies. It's very complicated. If you're not careful, you'll end up with some of your joints ending up in one or the wrong project, and things can get confusing. So probably step one is to, I don't know, let's split up this joint. And is everybody familiar with the split body command?
Yeah.
All right, so I'm just going to pick the face and hit split. And that I always kind of keep track of what extra pieces are showing up when I split stuff. If I get things I'm not expecting, then I know I've made a mistake. So this makes sense. I've got these two extra pieces, and that was my intent, to get rid of those. So at this point, I'm just going to go hog wild and delete them. I don't need them. I'm going to build new ones. So to build a new mount, the first thing I probably want to do is create a sketch. And I'm going to do it this way. I'm going to do an offset plane. And I'm going to create the plane on the back of this mount, because that's where I want, again, thinking about printability, I want this to lay flat on the bed, and the back of it's going to be on the bed in my design. And if I do anything that changes the flatness of that, I'll try to avoid it. So here's my offset plane. I'm going to hit OK. And here's a fun thing I learned recently. You can kind of stretch this plane around by just floating your, see how the line turns green? And it's not necessary. The plane's a plane. It goes forever, but it's kind of nice not to visually have a big chunk of messiness all over your screen because they tend to obscure your vision.
So Tim, why do you draw on a offset at 0 as opposed to actually draw on the plate?
Well, the reason I don't always do that, but if I just grab that and drew a sketch, it's going to import all this extra geometry that I frankly am not interested in, and it can get me confused with extra lines and dot. It's just more clutter.
Yeah.
So I'm going to go in here and I'm going to create a sketch on this brand new plane. I hit it when it does that. But the only geometry I'm interested in from that whole piece is this. So I'm going to hit that, project with the P key, and hit OK. So now this is the only bit of geometry from the previous model that I have to be concerned with. And I think
this is really quite an important point, that because when you draw on the plane, when you draw on the actual face of the model, it knows where all the edges are. It knows where the circles are. It will attempt to snap to those edges and circles. When you draw in what you think is a continuous perimeter, it can sometimes segment that through the existing design on there. So by doing the offset plane at 0, you effectively, it's like starting a new sketch in a notepad, isn't it?
It is. And the feature where it automatically imports the geometry or projects the geometry onto your sketch, that's an option. And I've been afraid to turn it off because it's so entirely useful most of the time. But some of the times when you're particularly modding, you don't want that extra distraction geometry or confusion that it can generate. So the first thing I'm probably going to do is just randomly change the shape of this. And I already don't like how this is working. So grabbing this 2-edge triangle thing, you can see, here's the error already. This is not lined up with that. And I tend to I don't like that. So I'm going to undo that. And I'm just going to take out Yearly line tool and just be a little bit more precise with it. And everyone knows how you can train by selecting something. And I'm right now, look, I got 90.6. It's not really, I always make sure I'm getting 90 degrees out of things or known angles out of things. And here's one thing I will also do. Now that I've got that, I'm going to select this line and go X. And you notice how it turns to a dotted line. So now that is just a construction line. We talked about that in the preamble. And that's not going to, and I'm just going to close this off and put my own line in it. So although I started the other thing as a projection, and now I've kind of divorced myself of that other geometry. So if I need to change something, I'm not entirely locked in there forever, or it's just a little bit less confusing to me. And when I kind of, like I said, divorce the geometry from those projected things, because that can really get you into a lot of frustration. We're like, why can't I change this? Why is this not working? It's because these constraints. So in this picture, you can see this line is black, that line is black, this line is blue. That means that this is not constrained, which in this model is probably fine, but I'll just eyeball it and put it there for now. And you can see this line, black, that's constrained. So I've got one unconstrained line. If I were to, I don't know, put a dimension here with the D key, that's over constraining it. Maybe here. Does that doesn't go black? The constraints can be a little bit of an art form. But here's something I do want to do. I want to have my servo not fall off the edge of this. So again, I'm just going to draw some lines. Oops. Draw some lines from here. This is even the better way of doing it. Here's why I talk about overdraw. So I just put this line up here as a kind of a target of where I want to go. And then rather redrawing this line, I'm going to go modify, extend, and see how that little red line pops up. Beep, and here. And then I'm going to trim off, hit the T key and trim off the excess, and then get rid of this. So now if I float my mouse here, you can see I've got a nice new surface I can mount that servo on. And while I'm at it, I'll probably do the same thing down here. And we'll do the trim, trim, trim. And I tend to like symmetry. So I don't know. In this session, I'm probably not going to do it, but I'd probably find out where the center point of this is and make that a construction line and just make these the same length if I could, or put the center, but I'm not going to go into that much detail right now. So the other thing in my servo mount is clearly where the servo screw holes are. So now I'm going to hit the P key and I'm going to just project the centers of these circles, or these 4 circles. Hit OK. And now I've got the centers of those circles, and I'll come back to those in a minute.
And where you've got, sorry, Tim, where you've got real world components like the servos or magnets or bearings, how do you get them into Fusion? Do you manually model them, or?
Well, that's a great question. Sometimes I will take a known good. This is the 996R servo model, and initially, like I would model my own servos, but then I kind of have a stable of ones that I mean, I've downloaded some off the internet and they are of questionable accuracy. But once I find a good servo, I use that and I import that as a component or just a cut and paste from another model. Another place to get things, and my screen's still sharing, so let's go back here to, for example, Chopper. And if you look at Chopper, a lot of websites will have the step files that you can import directly. So this RC62, these are all magnets that I downloaded, the step models from KJ Magnetics. This pogo pin I modeled, but if you go to GrabCAD, they have things like this, or maybe I got this from Pololu. This will take a second to open. But they had a model of their board in CAD. So, but grabcad.com is a place that I'll go to for like buck converters or whatnot. And in this model, you can see what I did. This is a Pololu product, but I added the geometry for the little mounting pads. So when I import this model, all I can get right to attaching it to something because it's already got the offsets and whatnot built into. Like I said, I added that to my version of this component, and this I would just, for example, I'm going to close this. If I were to finish this sketch on this sidebar, if I wanted to import that in here, I can just right-click, insert into current design, and after a few seconds of wickering, it'll allow me to place it somewhere into this model. And you can see my little progress bar. It's going to take a second to download off the internet, and here it comes. All right, so you can see the important things. I got this Mini Maestro 18 channel. I've got the chain, meaning that this model is not editable without a couple of hoops to step through. And then I can place it anywhere. And usually I just do a raw place. I'm careful to always spin things 90 degrees so I don't end up with some kind of weird twist to the model. But if I, for example, wanted to integrate this Maestro onto this mount for some reason, you can see there we have it. And then I could, combine pieces, and that's, I think that answers the question.
Another good source, if you go up to the top, you go insert, and you can insert McMaster car parts directly.
Yeah, they used to be McMaster car, and just recently it's now trace parts, which I clicked on that the other day, was a little upset because you might have to do an account. I'm sure you don't have to spend any money, but I just, like this bolt here, I actually went to the website, exported it, and then imported it because it was no longer an easy insert from McMaster car. Oh, there it is. Never mind. Take all that back. I just missed it. It used to be at the bottom, and now it's not. Yes, I use this a lot.
You get all any of your hardware and such is good for inserting screws and such.
Exactly. And I don't normally model screws or put screws in unless I'm trying to show an explicit assembly, like in the instructions, or theoretically you could do a hardware bill of materials if you modeled all your screws and put them in, but it adds a lot of extra computational requirements on your models. So the less things in your model, the better in general. And I'm going to undo all the way back, and we'll go back to where we were, because I don't want that extra overhead of that Maestro in our model. So
one more comment there before you continue on. You were mentioning, excuse me, about reducing your throw on your servo.
Yes.
Just one comment on that is that you're also reducing the torque and the resolution of your servo when you do that.
Well, indeed, it's a trade-off. As anytime it's torque versus speed, like it's one of those trade-offs. But in back in the design philosophy, right now I'm not asking a heck of a lot from this servo with the weight of that tool. It's not a metal tool. It's a few grams, a few ounces of weight. The biggest drawback on that tool is it's long, so it itself has a lot of torque, opposing what I'm doing with the servo. But this servo can handle it, and it's like I said, it taken to its nth degree. You're correct, but kind of back in the design philosophy, I'm not asking too much, but I want to make sure that it's easy to program, easy to set up, because the frustration is when you that I found when I'm mounting a servo arm onto a servo, if I click it this way, it's not enough. I click it one tooth to the left, that there's only so many splines on that servo. That's too little. Or so it's just, I hate being in between clicks. And if I can give myself the ability to use either one of those and then get out of that problem by using my servo range slider in the Maestro control panel, then it's a much easier resolution to that problem than being right at the limits of the servo. So I tend to
For sure. Yeah, you don't want to be right at the limits. The good thing with gears too is you can rotate the gear slightly.
Yeah, it's way easier to put together.
The other way, right? So you just want to mention that you are reducing the resolution. So as you turn it, you're going to run into a finite step eventually when you're doing a large reduction like that.
But this is about a 1.6 reduction. It's not even 2 to 1. And it just, again, that it's part of the design philosophy that in my head, I think it'll work, but when you print it out and put it together, That's the proofs in the pudding. Will it work? And that's part of the reason why I do the components, so I can do the motion range check and make sure that it's going to do at least as I'm expecting it. It may not behave that way when I build and print it, but at least I've asked and answered the question to the satisfaction of it may work. Whereas if I don't do that, I have no idea if I'm on the right path or not.
Yeah, most servos, you should be able to get at least 120 to 180 degrees total rotation on a servo, right? Even the low end ones.
Yeah, that's true. And I find that every servo is different. And if I swap out a servo, I got to retune its range of motion, because that Absolutely. 1500 microseconds I'm sending it may or may not be center. And I like having a lot of extra play in my ability to tune that servo. And it's for me, it's nicer to work in a setup like this. All right, so what I've done is I've extracted the relevant geometry of my servo master, and I've built a little thing that I can extrude as a mounting point for it. So I'm going to finish sketch, let it think a little bit, and then since I don't have any of that extra spare geometry, I'm just going to hit that and hit E key for extrude, and I'm just going to make it right now as thick as the other, but at the end that probably won't last. And here's the problem. Look, we got objects to cut, and you can see I'm my servo disc and I don't want to cut anything. I just want to extrude. And in fact, more often than not, I'll just go new body. That way I know I'm not going to cut anything, and I'm not going to mistakenly take a chunk out of something or merge it to something that I didn't intend to. And right now, I'll tell you what, that's too thick for my liking. I'm gonna kind of stop it here. And does everybody know how you can click on a face and it's going to automatically go to that distance? And it comes out to 5.615. I don't like that. I'm just going to make it 5. Just as I like, if I can, rational integers or reasonable numbers. So I'll just go with that, 5. So now you can see the problem is I don't have a cutout for the servo to fit in there. There's a number of ways of handling it. I'll just go short and sweet. I'm going to do the split body. And in this case, it picked that. I want to pick this body and that face split. I'll do the same thing again, split body, this body, and this face. Oops. This body and that face. And then finally, let me turn this off. Beep. There's a little bit left here. This body. This body. And this face. All right, so now I've sliced up my my mount, and this one, there we go. Yeah, so this, I don't want that at all. And the rest of these, I want them to be one thing. So I'll just hit combine. And if I've named something, I'm always going to pick on the name of it first so that it doesn't rename it. I end up with a bunch of unnamed bodies. And so there's my servo mount. What's missing is clearances. Let's say, and this is where I use the offset, minus 0.25. And I hit the, I guess it's the Alt key or the Windows key on, or the Apple key on Windows. And you can see, I always kind of test it. I'm pumping that key up and down now that I've selected all those spaces. And that's going to give me a little bit of clearance so the servo will actually fit into the mount. So at this point, if I were to combine this with this, I'd end up with one body, but right now it doesn't look good. And what doesn't look good about it is I've got this unnecessary tail here that at this point it's not really serving a purpose. So I'm going to slice that off and get rid of it. And this is not tall enough. So let's delete those two faces. Whoops, undo. Maybe I could delete one of them. There we go. And then let's just kind of bring this up. I'm going to bring it past it, some random spot, and then try to decide the best way of doing this. Oh, I don't know. I'll probably end up just slicing it again. And split body.
If you did a Q move face, you could snap it to the corner. Wanted to do that.
Yeah, I think I'm gonna just go there and redo that that chamfer. And this is, you know, caveman kind of big bold slices, just for expediency. So my original servo arm base is here now, and I'm going to use that as my basis. So combine this, this, and this, join, and put it all back together. And so now theirs are nice and pretty. And if I wanted to add a little more strength in this, because this is a natural stress point right here, this sharp angle. I kind of like chamfers over fillets, just because I think they 3D print better. And you see I'm having a problem here. The problem is there's an extra face right here that's unnecessary. So if there we go, I can just delete it. So anytime I see extra lines or things I don't expect that aren't adding to geometry, that's a potential error that can haunt me later. So back here, go to chamfer, and something like that. And what I tend to do is just come in here and then delete this. And that makes it, it screws up my thing. I'll undo that. I'll leave it like that for now. We don't need to make it super pretty for the work we're doing here. So at this point, I'm probably happy with going and combining this with this. And now I have a servo mount that will work with my gear geometry. Does my gear geometry work with my servo mount? And so I'm looking at here, and I use the inspect key a lot. So I hit I, hit that, and I see a bad thing just happened. I was expecting a distance and I got an angle. A really, 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 really small angle, but an angle nonetheless. So I've got some underlying geometry bad thing happening here that I don't know I want to spend the time in this Zoom to solve. But the basic thing is I have to I use the align command. Let's see if I can do it real quick. So the basic problem is my gear is not lining up with my mount, and it's a super small degree error. So what I'm going to attempt to solve it is I'm going to use the align command. So in this, I use align, and this is very critical what you pick to choose to align to what. So in this case, I'm going to align the very bottom ring of that gear I'm going to turn that off so I can see and turn this on with the very center of my mounting servo arm horn. And I'll turn this back on and see what happened. It looks like that's exactly what I was expecting to happen. So we'll hit OK. Now let's see if I have solved my problem. 0 degrees, that's good. But I still don't see the distance between them. That's weird. Inspect that. Huh. Usually I'd get like a nice little number there and I don't see it.
If you choose an edge or a point, I think you'll get the measurement. If you choose 2 faces, you don't.
Huh. Well, all right. The problem is, well, I guess we'll try this. That one and that one. Oh, I have to inspect. There we go, 0.5 millimeter. I'm happy with that. Although, if I could get to a millimeter, that'd even be happier. In fact, let's just say I wanted a millimeter clearance. And here's a perfect reason to use an offset of 0. Construct offset 0. And the only thing I want out of this thing is its center. And so, because otherwise it's going to grab all those gears and it's going to be a horrible, horrible thing to try to select that and then extrude. Like I don't want any of that gear geometry. So what I did here is I clicked on the face and then I'm going to add, let's say 2 millimeters of clearance to that, and then objects to cut. I'm going to make it just my servo lifter. And so now I've got a healthy amount of clearance, and that gear can wobble a little bit and not run into anything. All right, so we are at 1 hour and 5 minutes. I'm going to save this. How far do we want to go to try to build another gear? Open it up for questions. Certainly, we probably should do that.
Well, yeah, do some questions, and then if you send me that save file, I can put that one at the end of that, and we can pick it up on the next session, I think.
Okay,
cool.
I'm going to stop sharing. Well, I'll stop sharing for a second so I can see people's faces, and then we'll share if necessary. Yeah, so here I'm back. Go ahead.
So gauge that. I mean, how was that? How from everybody? Did we follow that? Yeah, got a nod from Scott.
Well, I was going fast and furious, kind of, because there's a lot to talk about. I really wasn't explaining my key clicks a lot. Assuming that a lot of the stuff I was doing is fairly common, but the way I was doing it maybe or maybe not the way you do it or have done it in the past. Not you, any particular person, but the ubiquitous all y'all. Is there anything I did that you'd like me to expand upon or was too fast or not clear or confusing?
No, it was, for me, it was clear. It was interesting watching you, like I said, you do things a little bit different. I've not played around with the sketches. I quite like the trim, actually, which was quite cool. I live and die by these things, which is there's no doubt you do too. Yeah, exactly. So we'll use these two.
You can't. Yeah, I've got even though I've modeled screws and nuts and spaces, and I still always kind of verify, okay, this is this. And the other thing that I keep in mind, which I didn't mention, is I didn't used to, but now I think of what size a nozzle is going to be used to print this. because that's going to increase or decrease your clearances. With a lot of these big 0.6 and 0.8 millimeter nozzles out there, if I'm drawing a circle and I planned it for a 0.4 millimeter nozzle, it's not going to have the same clearances we were expecting on a 0.6 or 0.8 millimeter nozzle. So when I'm building big stuff that I expect people to use big nozzles, then I tend to put that into the notes and into the design of how big those holes are. In particular, holes can be trouble.
Got it. It's okay, John. We've recorded it, so there's even though you joined at the tail end, you can watch the video. Cool. Okay, so no questions. Massive thank you, Tim. We'll obviously do a second session then and start to get into adding the mechanics. And what I'll do is I'll share if you send me the one that you've got now, the one that you've just saved, I'll put that in the folder so you've got kind of a before and after so people can play with that. And then for me personally, I learn by watching, how you do it and some of the basics. Like for example, where you're cutting into an object, I've never noticed that little selection box underneath where you can choose which object you're cutting into. Just everything, So what I've done often is extended as a new part and then done a combined cut with that part specifically to what I'm trying to cut out of. But so you just pick little hints and tips up. So brilliant. Thank you.
Well, it was fun. And I'm happy to, if anybody has any questions after the fact that you didn't think of, hit me up. Probably the best way of doing that is maybe as a message rather than a direct message. So if other people had that same question, that discussion can be viewed by all, or at least the people who care about it.
Definitely. And if I know a lot of people tend to watch these videos afterwards, so if you're watching afterwards, equally feel free to ping a message. We'll probably do the next one in a couple of weeks, I guess. We'll sort diaries between us, Tim.
All right, sounds good.
Thank you, Tim. I think for a beginner like myself, especially, it's just fascinating to watch you go through it. And like Michael said, I pick up just by watching, I pick up some of the basic things too. So thank you very much.
Well, thanks. It's been my honor and pleasure. And I'm a kind of an instructor at heart. I've been doing that my whole adult life. And maybe I'm not good at it, but I like doing it.
You're good.
Oh, you're good. Very good. Cool. Okay, guys. Have a lovely evening or day or whatever time it is. I'll catch you all soon. Cheers.
Thank you, Michael.
All right.
Take care.
Thanks.